Yeah, hi everyone. This is Aman. Today we are going to start with computer networks. I'm going to make this video on a playlist on the whole sub syllabus of the computer networks. And since it is a theoretical subject, I'll try to keep everything crisp to the point and not going too much in depth to everything. This video or the playlist will be useful to the people who are like supposed to revise their concepts for coming gate exam, or to the university people who are about to write their semester exams. They can also get benefit of it. Also to the people who are planning to switch or on a job hunt, and if the company is asking uh, uh, computer network questions, then you'll be able to get benefit of it. So to start with today's topic, starting with what we have, I have my notes prepared right here. So I'll just try going through each and every topic. Starting with discussing the topics what we have in the computer networks, that is the very first chapter is like IP, that is Internet Protocol. So the version we do have in universities in India, that is V4. We need not to go study V6 and all. And Of course, we are going to read about the addressing of this IPv4. Then comes the chapter that is error control in computer networks. And of course, we have data flow control. This data flow control is at DLL, data link layer. And the very next chapter or the topic we could be covering is the protocol versions. We do have different internet protocol versions like IPv4 and all, IPv4, 6 and all. But in this topic, we will also be covering the fragmentation part and the header part. So let me just write the topic right here. So in this topic, we are going to cover IPv4 header as well as the fragmentation. The very next topic would be like transport layer protocol, that is TCP. And then we have UDP, user datagram protocol. And we have several media access control. And the routing protocols. So there are also few small topics like switching. We have application layer protocol. We have basic IP support protocol and the OSI TCP, of course, OSI TCP protocol stack. These are mainly these topics are covering theoretical part. Not a lot of numerical part is there. So I'm not going to write it on board since it's just gonna waste our time. These are the important topics we will be covering in this playlist section. Along with, I'll try to make a video covering the rest of the topics in one go. So without delay, we'll start with this IPv4 for today's session. And let's see how long we can record this video. Let me just rub this everything out of the board. Yeah, so few things I just wanted to give a brief about the binary numeric part before starting with the IPv4. So we have as we or like that there is a standard of like we have IPs of 32 bit. So anywhere you go in world, everywhere the IP is of 32 bits. So we can at max make 2 to the power 32 IPs only. So and few things it would be good if you guys have grasp on it, like with 1 bit of address we have 2 choices. And how come we have 2 choices? That is from 2 to the power 1, that is equals to 2. And with 1 bit the options are like 0 and 1. Similarly from 2 bit address we have 2 to the power 2, that is 4 choices, and the 4 choices can simply be represented as 0 1 0 0 0 1 1 0 and 1 1. So these are the 4 choices we have with 2 bit of addresses. These choices can be considered as IPs only. So similarly with 32 bit of address we have choice of 2 to the power 32 IPs. Yeah, so like I've seen a lot of guys face issue while remembering these bar terms. So to make it a little bit easier or simpler, I would just like give a brief of it. Like if you have 1 bit or 2 to the power 1, I can say, then we can write it as 2. If it is 2 to the power 2, it's 4. 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. 2 to the power 6 is 64. 2 to the power 7 is 128. 2 to the power 8 is 256. 2 to the power 9 is 512. 2 to the power 10 is 124. So similarly, you can keep on increasing the power to the base 2. We will end up getting the result multiplied by 2. So similarly, 2 to the power 11 is somewhere around 2048, and it's keep on going. So usually you might need to remember these along with this, and it would be very much easy for you if you do remember this 2 to the power 16. I also might not be able to remember, but it is 65536, somewhere around. Let me check if I'm wrong. No, perfect. We are absolutely right. If you are facing issues while remembering this, no, it would be like we could simply use a split method of the power. That is 2 to the power 16. We can write 2 to the power 10 into 2 to the power 6. Like simply to give, if I just to give you a better visualize, 2 to the power 16 is 2 to the power 10 plus 6. And it could be written as 2 to the power 10 into 2 to the power 6, that is 124 into 64, that is 65536. So this is 2 to the power 16. If you would like to get 2 to the power 32, it would be simply as 2 to the power 16 plus 16 that is 2 to the power 16 into 2 to the power 16, that is 65536 into 65536. So it would be somewhere around like a quite big number. So we do have choices, we do have a big choice with 2 to the power 32. So that's why it is more than enough for us as per current uses. So 2 to the power 32 IPs are enough. We would be able to fulfill each and every demand of ours at current time. Okay, so let me just erase this. If you would like to note this, you can pause the video and like write it over the notebook. It would be very much easy while you guys will be revising the topics. Going to the next topic, let me just check my notes. Yeah, similarly, few of the data convergence, like uh, if you have given things in format of like data size or the bandwidth size or something like that. So in cases of that, 2 to the power 10 is considered as 1k. So you can say a k or 1k. Similarly, 2 to the power 20 is m. 2 to the power 30 is G, that's called giga. 2 to the power somewhere 40 is tera, that is represented as T. Similarly, it's also like you guys have noticed, K is 2 to the power 10, it's also could be represented as 1024 on multiplying 2 to the power 5 into 2 to the power 5, that is 32 into 32 exactly. Similarly, 2 to the power 30 is 2 to the power 10 into 2 to the power 10 into 2 to the power 10, and this is somewhere around like 124 into 124 into 124. So this 2 to the power 24, if I would like to link this with the number of IP bits we have available in current world, that is 2 to the power 32, and it could be written as 2 to the power 30 plus 2, that is 2 to the power 2 into 2 to the power 30, that is 4 times 2 to the power 30. So this whole value comes here, and if you would like to simplify it further, you can do it, but there is no necessity of doing those exercises, so we'll just skip for this video. Okay, coming to the classful addressing, we have entering to the this is more than enough for the numeric binary numeric part. So I'll just erase this thing, and we'll just go on introducing the classful addressing. So in classful addressing, we basically divide our current IP system of 32 bits, that is 2 to the power 32 IPs, into some categories. That's called the classes. So that's why it is called classful. So those classes could be like class A, class B, class C. Similarly, class D, and also we have a class E. To represent in a pie format, we can say if we have the whole 100% as the IP, which represents 2 to the power 32 IPs. So I'll just draw it phrase, right? Instead of referencing from here. So let's say it is represented 2 to the power 32 IPs, and I would like to classify into different categories of class A, class B, and class C. So I'll basically explain you why we divide in class A, B, C, and C, D, and E. There is a concept of network ID and host ID. and we use subnetting and these concepts. That's why we need to divide this class A, B, C, D, E, and E category. Also, like the number of IPs fall in each class differ uh, with a quite large number. That's why we need to, since let's say some organization would like to buy some part of the IP addresses. So they came on asking like, I need an let's say class A IP address, and the firm is like not that big, and suppose a class A is containing a large number of IPs, somewhere around in class A we have a 8 bit of host ID. Sorry, for class A we have a network ID of 8 bit and host ID of we have 3 more octets to 18 to 324. So we have 24 bits of host ID. That means we have to keep 24 IPs in class A. And let's say some organization which have only 10 employees would rent this class A IP, then they end up wasting a lots of IPs. And it's not just about the waste of resource, it's also about the waste of the money. They like the extra amount of money they would be putting into renting these IPs, which they are not going to use in coming future, or like they are not using right now also. So there is no meaning of buying all IPs. That's why we needed this classification of IPs into different categories. Let me introduce you with the pie chart. If say we have a 32-bit of IPs, with 32 bits we have 2 by 32 IPs, and for class A, I assigned the 50% of the IPs to class A. So that is like, for 50% assigning to class A, I'll just let's say these 32 bits could be represented as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Some similarly goes to 32. So let's say this is the first bit. This represents second bit. This represents third bit. This represents fourth bit. And similarly goes, and this represents 32nd bit. Let's say if I fix this first bit. So if I fix this first bit with 0 and rest I am left with 31 bit, since I have fixed only one bit of 32, then ends up left with 31 bit. I am left with 31 IPs in class A. That is 50% of what we have of the total IPs. Now for class B, I am further dividing into half. That is, I need to fix the first 2 bits, that is first and second, that is 0 and 0, and rest I am left with 30 bit. Ends up creating 30 IPs for class B. I hope you guys are able to get aligned with me what I'm trying to explain. Similarly, we further divide the rest of the part into half. Ends up like securing 2 or reserving 3 bits from a start, that is 0, 0 and 0. And we are again left with let's say we have 32 bits, and if we subtract 33 from 32, we'll end up getting 29 bits. So we are having 2 के पास 29 IPs in class C. So let's say if I'm an organization that have only 10 employees, so it's again waste of resource on the money I'm going to put in. If I need to buy like class, if I'm going to buy this class C or class B or class A of the IPs. So we further subrogated this whole concept into class D and E. So there is also a concept of like you guys will be like still we are having 229 IPs, and if I'm having only 10 employees, then in these cases the IPs are going to get wasted. But that's not the case. We do have a concept of subnetting as well. And if we are having a, let's say, organization or somewhere around uh, just more than 2 people 29, let's say we are having an organization which have total employees with this with total requirement with of this much IPs, then again we are going to buy. We are not left with any other category else than to B, and it is again like quite less than, very much less than 2 power 30. So again, a lot of IPs we are going to waste if we are going to buy class B. Instead, we can go with the concept of subnetting in class C. We'll discuss those things later point. So I'll just erase to keep a clear head on just the classful addressing right now. In class D also similarly we reserve the first 4 bits like 0, 0, 0 and 0, and rest we are left with 28 bits. And similarly in class A we reserve the first 4 bit, and we again left with 28 bits. The last, that is this one. And in class D and E we both have took about 28 IPs. So it is true for both class D and E. So I believe this much explanation is quite enough for your revision of classful addressing. So we again have a concept of classless addressing as well. And like it's not like we are just using the classless addressing in today's world. Like a lot at lots of places, organizations like Cisco and IBMs are still using classful addressing while providing their services in the networking department. So like that, there is a very much wide variety of uses of classful as well as classless addressing. So I believe this is enough for today's class. Or let me just check, we can cover some more details. Yeah, I would like to just cover this network ID, since I've already started the concept of this thing. So let me just explain what is network ID and what is the host ID in the IP addresses. Since we have 32 bits of IP address, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So let's say it is first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21, 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30, 31, and again we are left with 32, right? So these represents 32 bits of the of an IP address. We divided these 32 bits into 8 different octets. So 8 goes to first octet. The second one is like 1, 2, 3, 4, 5, 6, 7, 8 goes to second octet. 1, 2, 3, 4, 5, 6, 7, 8 goes to third octet. 1, 2, 3, 4, 5, 6, 7, 8. So we divided this 8 bit 8 bit and 8-bit octets. These are called octets. Since we are dividing 8-bit to each category of 4 categories into the IP addresses, that's why it's called the octet. Obvious regions you would be able to conclude from the word itself. So I was explaining network ID and the host ID. This is network ID and this is host ID. So network ID represents a network in the into the internet world, and the host are like the computers aligned with a single network. So let's say we have several networks built around us, and our computers, these computers are divided into different categories of network. So this is how the internet works. These networks then connected with each other with different topology way. We'll be going through these topologies at later point of the time. Let's not go. Let's go with the flow. So whatever we are trying to focus right now, right here. So these network ID and host ID we are talking about. We assign few portions of this whole IP address of 32 bits to host ID and few portions to the network ID. So this whole network ID plus host ID basically insert into 32 bits IP address, and on the basis of like how much bits we have assigned to network ID and the host ID, we get our classes defined in the classful addressing. So let's say if I'm talking about class A, the first octet, that is 8-bit, are assigned to network ID, and the rest of the 8 and 8 24 24 bits to host ID. Similarly, in class B, we assign 2 octets to network ID and the rest to host IDs. So basically it's like 16-bit to network ID and 16-bit to host ID. Same goes for class C. Class C, to reduce the number of hosts in a network, we like assign 3 octets to us to the network ID. 3 octets is like 24 bits to network ID and 8 bits to host ID. In class D and E, yeah, you might be thinking about what about class D and E. In class D and E, we don't have a concept of network ID and host ID, so no concept of it. Yeah, there are a whole lot of reasons why we did not require to use class D and class E to provide it as a service to other people like us who can use these network IDs to assign it to our host like computers and everything who is on the network. So we'll be discussing that part later. But for now, this is like these many things. Since we have 24 bits of the host ID, in the class A, we insert 2 IPs. So basically, we have 2 IPs in class A, with reserving 8 bits to the network ID. But we did not, not get 2 hosts in the class A. That's because few of the IP addresses are assigned for direct broadcasting or limited broadcasting. We'll be discussing about deep direct broadcasting and limited broadcasting at later point of the time. But for now, you can remember like 2 IPs are there that we have in class A, out of which 2 minus 2 hosts are there only. So 2 IP addresses we assign, one to direct broadcast, one to like limited broadcast. That's why we end up losing 2 from the whole IP for the host. Similarly, for 16 to the power 16 IPs, here we have 2 to the power 8 IPs. So I believe this is enough for today. We'll be meeting this much is enough for today. We'll be meeting in the next class, like the next video obviously, and I'll be recording furthermore of the information in the revision or the short video type. Thank you for watching. Bye bye.